Yo, what's up, YouTube? It's Crack 2 minute, and I have to study for analytical chemistry today. So, yo. So, from this question, I understood the ionic strength section. It's the formula with ionic strength I equals 1 by 2 sigma z is 1 by 2 into c z square, right? Yeah. So I got that. That is the, we're doing the math here. Oh, where's the math? I saw the math. It's the concentration of the anion multiplied by the charge squared plus concentration of the anion multiplied by charge squared, which is going to give you the same value. Okay. So that is the, yeah, that is the ionic strength. Now, other than ionic strength, it was, what's the other value? It was activity, that is lambda, which was log lambda equals minus a into concentration. Nah, z. Okay. This is the value of a. So so here the 89. That's so weird. Why did you do that? Okay, yeah, that represents a fraction of AG that is free for effective informing this. Okay, that is the KSP, not not KSP, but that is the amount of ions that is not under the cloud, and this amount should be 100. The salt will dissociate more to make this person 100, right? Yeah. Mm, yeah, okay, I got that. How and why does solubility change? I know why it changes. Please explain the reason for any change. So if I understand, I don't need to do the calculations. The solubility changes because so it's the ion shielding. Mhm. I get it. So I don't need to do the calculations. Mhm. I need to check into it. Yeah, I understand. It's so the So it's ionic shielding, which causes the crowd effect and traps some of the anions and cations that needed to be in the equilibrium or needed to represent KSP, which release. So it's ionic shielding and what? Physicochemical properties. These are physicochemical properties. Reduction in activity coefficients, quantity to manifestation. Hey Siri, set a timer for 15 minutes. Inert salt effect. Okay. So the addition of adding what was AGI? insoluble ionic salt. Slat salt! The fuck are these songs, bro? These songs are ass, boy. These songs ass. What? Apple, I noticed a glitch on Apple. So yeah, there are a lot of glitches, but this one's pretty weird. So uh, I have a. This is my. So what you're seeing is my monitor, external monitor to my laptop, which is on the right side. For you, it's the left side, but for me, it's the right side. Yeah. So on the laptop screen, I have four small tabs, windows, and no, three windows, like one here, one here, one here. That's how I arrange it on my monitor, laptop screen. The three windows are Google Chrome tabs, with one for the comments of Twitch, the other one for the comments on YouTube. The third one is for the the tab with Twitch or YouTube. Yeah, I have both Twitch and YouTube as a Chrome window, and behind this is my OBS streaming application. Yeah, that's how it is. So behind the whole window is OBS. There's Twitch chat, YouTube chat, and the Chrome window. With here is the section of OBS with the end of the screen. So it's almost like this. But Mac, sometimes right now it's confusing for the OBS window for being big. It shrinks it to small to fill in the third gap. It happened two times. This should not happen. If I give command to the fourth time, yeah. So if I give command to the laptop to make shrink it to small, it should shrink. It should not shrink on its own. Wow. What the? What? It's not good, bro. This ain't looking good. No water. You shut it. Clock in my lab. Fifth time. Stop. Stop, bro. Stop. Stop. Calm down. Ugh. Exactly. The phenomenon you're describing is indeed called the inert salt effect or diverse ion effect. Stop giving me new names. Okay. Inert salt effect. That's the effect caused by addition of sodium nitrate to the solution, causing the sodium ion, causing ionic shielding, which ultimately results in increasing insolubility. Okay, that's an interesting question. I'm shaking right now. The camera can't even see it. It's vibrating so fast. Interesting. For a precipitate to serve as a reliable weighing form in galvanometric analysis, it must meet these critical criteria: definite and known composition. The precipitate must have a fixed stoichiometric formula like AgClBaSO4. Fix it. What does that mean? Fix it. Oh. Mm-hmm. This was what I was expecting. So definite and non-composition, high insolubility, which like okay, I was not soluble. Hmm. The solubility product constant should be really low. Numbers such as numbers below 10 raised to minus 10. Okay, got it. Physical stability resists decomposition, must not oxidize, decompose loose volatile components during ignition, drying ignition. So this should resist decomposition. Barium sulfate. Be right back. For days. Potatoes for days, son. For goddamn days. You're gonna be eating potatoes, man. Potatoes, potatoes, potatoes. I wanna try if it's okay. BS for barium sulfate. So, if I understand correctly, it is. It is a what? It is what? Barium is a sulfide. No. I was thinking different, something else. What? It is a binary ionic salt. It is an insoluble salt. Okay, and it's also a crystal, right? Inert salt. Yeah, yeah, yeah. All the good things. So the things that needed to be what's the word? Things that needed to be സൂക്ഷിക്കേണ്ട what's the word to take care of? Prerequisites. Prerequisites. So which are the prerequisites for using a precipitate also as weighing form? So prerequisite for using a precipitate as a weighing form, according in the form of galvanometric analysis. Gravimetric analysis. Gravimetric analysis. What? The precipitate must have fixed stoichiometric. Like what? No variable water content. Hydrates are acceptable only. Stop. What are I know the answer. Why am I keep reading it? Okay. So what are the prerequisites for a precipitate as a weighing form? As a weighing form. So according to the gravimetric analysis, the these are the criteriums. It should be. It should have It should have a definite and known composition. It should have a constant stoichiometric formula, fixed stoichiometric formula. High insolubility. What else? Should be should be not prone to decomposition. Physical stability. Resist decomposition. It should be physically stable. Ease of filtration and washing. Particle size form large crystalline structures. What? Particle size forms large crystalline particles rather than colloids. So barium sulfate is a really good example as using as a weighing form. Good precipitate to use is a good precipitate to use as a weighing form. Okay, I understand. What's next? Unreactivity with atmosphere. No hygroscopicity. Must not absorb moisture from air after drying. Uh huh. That's a cool word. Hygroscopicity. It has a word like it's similar to hydro. The word hydro. It has the word gyro. It has the word scop. It has the word city. It's hygroscopicity. Oh, damn! That's an amazing word. No hydrographs. Hydro. No hydroscopicity. No hygroscopicity. Just tell them no hygroscopicity. No hygroscopicity. Just tell them no hygroscopicity, bro. We ain't playing, bro. The same game, bro. I'm telling you, no hygroscopicity. Must not absorb moisture from air after drying. Okay. Hygroscopicity. Hygroscopicity. So hygroscopicity is the property of is a property shown by crystals to absorb water from the atmosphere. Moisture, water, yeah. So this should be not hygroscopic and no CO2 absorption. Okay, so it should not react. It should be stable. Example: barium sulfide and silver iodide. Why these certain criteria matter: if the precipitation changes composition, absorbs water, loses mass, the results becomes inaccurate. A good vein form is pure, insoluble, stable, and easy to handle. My sleep time, yeah. So it should be pure, insoluble, stable, easy to handle. It should be. It should not be hygroscopic, right? Hygroscopic, yeah. It should not be hygroscopic. Damn, that's a cool word. Yo, stop being so hygroscopic, bro. Hygroscopic. Now there's two more questions, and I have almost reached the end of the day. Let us see how fast can we answer these questions. Uh, paste. Solution to the problem. Thank you, ChatGPT. No, it's DeepSeek. Thank you, China. Damn. Just imagine the best of the best are right in front of me. The product of the best right in front of me. But I'm still using Apple, which is American, but the parts are from China. So it's China itself. It's not made in America, it's made in China. So, yeah, I would say China takes the win. It's the software that Apple has, okay, but it's not like China cannot make software, right? So, yeah. Okay, what was please don't be a big answer. The relevant reaction equation. So Fe2 plus in you want to determine Fe2 plus. You want to determine the iron ion in a strongly acidic solution via manganometric titration to determine the exact concentration of potassium permanganate, yeah, solution. To determine the exact concentration of potassium permanganate solution, you titrate a sodium oxalate solution. For this purpose, you dissolve exactly 157.2 milligrams of sodium oxalate and titrate with KMNO4 solution. Okay, for the to determine the exact concentration of potassium permanganate solution. So we have to find iron through manganometric titration, and the concentration of permanganate solution. You titrate a sodium oxalate solution. For this purpose, you dissolve exactly 157.2 milligrams sodium oxalate, 134.1 grams per mole, and titrate with your consumption equals 19.6 milliliters. Subsequently, you use this permanganate solution to titrate 20 milliliters, 25 milliliters of sample containing iron, resulting in a consumption of 4.7 milliliters. Okay, please give all the relevant reactions equations with correct stoichiometry. Calculate the exact concentration of permanganate solution, how much iron was into 50 milliliters of sample solution. If you do this titration in a solution, how many times am I saying solution? Solution, solution, solution. Containing HCl, what is the potential side reaction that has to be considered? Wait. Score the Gone Banana April Fool. Nah, fuck that shit, bro. I'm not in none of that shit, bro. Don't show me that shit, bro. What, oh, oh. So the equation is what are the relevant equations, the relevant reaction equation, standardization of potassium permanganate with the sodium oxalate. I think this is oxalate, right? Yeah. So potassium. So okay, we're taking off the cations. No, cations. Removed the cations in acidic medium. Where did it say it's an acidic medium? No. Oh yeah, it's a strongly acidic medium. Okay, so in an acidic medium, sulfuric acid, uh, manganate ion, permanganate ion oxidizes oxalate to CO2, while manganate ion is reduced to manganese. Okay, so yeah, I need to know stuff like that. Um, is the I believe it's common for titration. If it's common, yeah, then yeah, it's better to study the equation, necessary equation. So mass concentration given molar mass, volume. Okay, step one, moles of sodium. Okay, find that. Moles of potassium from stoichiometry. Stoich, sto, stoichiometry. Stoichiometry. Yeah, whatever. Moles of this thing, sodium oxalate. The moles of sodium oxalate. Well, what did you do? You do grams. Okay. So moles of from the stoichiometry. Why? From balance equation, 2 moles of react with 5 moles. Okay, so you're doing the calculations. The number of moles of chromium. Okay, this way. Okay, okay, I get it. Or you can find it through. Oh, you have to know the density to convert. Yeah. So we don't know the density, so we can just convert it from stoichiometry. The keyboard is getting old. Uh, okay. Concentration of potassium per magnet. Concentration equals number of moles by volume. Okay, yeah, that's right. Nothing happened. Yeah, I think the calculations are pretty easy. I do remember doing that I do remember doing these questions. I do remember doing these questions for the analytical exam that was before the one that's happening tomorrow, the past one. So I do remember finding the answer for these questions much faster. So it should be good. I'm not being too cocky right now, but yeah, I think these two are pretty easy questions. This one was pretty easy, but you know the theory part that you gotta know, right? I just how and why does the solubility increase? I just wrote yeah, the solubility increase because duh. No, you gotta give the reason. So yeah, I do believe I can do this test. So I gotta smoke. I'm just gonna go sleep.